Okay, so this is 3.4a, college algebra, and the name of this section is Theorems about Zeros of Polynomial Functions. Now, 2 lessons ago, I said in 3.3 and 3.4 we were going to figure out how to factor down these huge polynomials that have exponents that are larger than 2. And we started doing that in 3.3, and we're going to continue that in 3.4. And first thing we're going to learn, which seems kind of silly, the fundamental theorem of algebra, basically says that every polynomial has an answer. Okay? And as we continue down to the bottom of the page of 290, it says every polynomial that has a degree n. So basically just the same stuff I've been saying has this many answers, okay? And it does say that they're not necessarily unique answers. And I've said this before, if something has a multiplicity of 2, it means that the answer occurs 2. So it could be that I get an answer like x minus 3 to the 4th power for an answer. So the answer is 3, 3, 3, 3. So there's 4 answers. They're not unique, they're not different, they're the same, but there's still 4 answers, but we just write it as one answer, and that's what they're saying there. So, top of page 291. Basically, a little bit more math philosophy here. If we have several numbers, like 2, 3, and 6, we can find a polynomial that has those numbers as its answers, those numbers as its zeros. So what does this 2 mean if it's a 0? It means when we plug it into x minus 2, that doesn't look like a 2. If we plug that in there, we get 0. So x minus 2 is a factor, x minus 3 is a factor, and x minus 6 is a factor. So if we multiplied all 3 of these together, we'd get some big polynomial that has, because we have 3 answers, that's going to have as its first exponent a 3, and it's just going to have a whole bunch of other stuff there. So if you did the FOIL method and found out those answers, you would find out what equation, and there's millions, there's an infinite number of equations that have for their answer 2, 3, and 6. But the easiest one is when you just multiply those together, and you'll get one of a multitude of equations that work for that. Okay, so let's look at example 1. It says find a polynomial function, or basically find an equation that has a degree of 3, so it has an x cubed in its as its first term, a degree of 3, which also says it has 3 answers, having for its answers 1, 3i, and negative 3i. So there's my 3 answers. So I need to come up with an equation. Well, the equation is find factors that when I plug this in is going to make it equal to 0. So x minus 1, if I put a 1 in here for x, I get 0. So therefore this is one of the factors. X minus 3i is a factor for that. X plus 3i is a factor for that. Now if I multiply all these puppies together, I'm going to get x minus 1 in here. Doing the FOIL method, these are going to cancel out, and I'm just going to get x squared plus 9, because this times this is I squared, which is negative 1, which makes it a positive 9. You can go ahead and do the math if you want to. And I keep multiplying. Do the FOIL method. X cubed first, outside, inside, last. Put them in the right order. And I get that. So how do I check? How do I know that that is the equation? Well, it's pretty easy. I can do 1, negative 1, 9, negative 9. And I can put a negative 1 in here, or I'm sorry, not a negative 1, a 1 in here, and do synthetic division and see if I get a remainder. If I get a remainder, then I'm wrong. This is not the correct answer. If I get a 0 for a remainder, that means it works. So 1, 1, 0, 0, 9, 9, 0. I got a 0 for a remainder, so that means 1 is, in fact, a 0 for this equation. So I know it works. I mean, that's just a way to check it. That's all I have there in that bright yellow is just a check. It's not the answer. The answer is this here because it said, give us a polynomial function. Give us a problem, an equation based on that I, 3i, and negative 3i being the answer. So they gave you the answer and they're asking you to come up with an equation. Example 2 says find a polynomial function of a degree 5. So it's going to have an x to the 5th as the degree, with negative 1 as a 0 of multiplicity 3. So negative 1 is going to show up 3 times. So 3 of my 5 answers are going to be negative 1. And 0 as a multiplicity of 1. Okay, notice what I've got there. Oh, and I was going to do something else. And 4 is a multiplicity of 1. I skipped that part of it. All right, so there's my 5 answers. What do my factors look like? X plus 1, x plus 1, x plus 1, x minus 0, and x minus 4. Okay, so it's always going to be the opposite. The numbers that go in here will be the opposite of the answers. Well, except 0, but it doesn't really matter there. Now I just go ahead and multiply all this through. So I multiply this times this, times this, times, well, that doesn't give me anything. Well, it gives me an x, and times this. And when I'm done, I get x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x. And I'm not going to go and do all that work. That's just how you do it. Okay, you do the FOIL method 5 different times. 4 different times, and you get that for an answer. Okay? Alrighty, let's look at zeros of polynomial functions with real coefficients. Real coefficients means real numbers as coefficients. Okay, so that blue box, bottom of page 291, talking about non-real zeros. Non-real means that we've got i's. So if we have an equation and we find out that 2 plus 7i is one of the zeros, okay, we find out that that's one of the zeros, that's one of the answers, just like 3 or 4 would be. This, remember, is not a variable, it's an imaginary number. So it's basically, we just wrote our answer as a plus bi. And again, I can write that as a plus bi. And I can write that as a plus bi. Okay, but since there's 0 i's, we don't need it. Since there's 0 i's, we don't need it, and it shows up as 3 and 1. And we went over this a long time ago when we were doing imaginary numbers. But let's say that we got this as one of our numbers, one of our answers. Well, if that's true, what this theorem is saying is that its conjugate is also a factor. So if this is a factor, we also know a second factor, because non-real zeros occur in conjugate pairs. Meaning, if one of these is a 0, then the conjugate is also a 0. So when you find one of these, you found 2 of those. Okay? All right. Okay, the good news is that irrational zeros work the same way. So, for example, if we got as an answer that its conjugate is also an answer, okay, is also a factor, or a 0. So again, if you find one of these, you found 2 of them. So that makes it real nice. All right, so let's look at example 3. So example 3 says, suppose we have a polynomial function with a degree of 6. So it has a 6 as its highest exponent, with rational coefficients like this, this, and this as 3 of its zeros. Find the other 3 zeros. So negative 2 minus 5i conjugate, conjugate, conjugate. Okay? Pretty easy to find. I found the other 3 zeros. So I just found, given 3 zeros, I found all 6 of my answers there. So if I wanted to write these in factor form, I'm going to do this. And so this is going to be multiplied by x plus 2i times x minus 1 minus the square root of 3 times, the x with that, the x with that, the x with that. So it's going to be this really, really crazy mess. I'm not even going to erase that. I'm just going to delete it all. Okay, so that takes us to example 4. So example 4 says find a polynomial function, or find an equation there, of lowest degree. So we want to find the smallest equation, meaning we want to find the equation that has the smallest leading exponent. The biggest exponent is going to be such that whatever other equations there are out there that work, this one is going to be the smallest one. So it says find a polynomial function of lowest degree with rational coefficients that have 1 minus the square root of 2 and 1 plus 2i as 2 of its zeros. So 2 of the answers to this equation that exists out there are 1 minus the square root of 2 and 1 plus 2i. Now I know, because this is a radical and this is a complex number, my other answer are going to be this, and this is all I know. Okay? I can't say there's other numbers out there because I don't know what they are. I don't have enough information. But I know these 4 work. Well, and it says the lowest degree. Well, if these are the only numbers I can come up with, even though there may be others, then the lowest degree on this polynomial is going to be a 4. It's going to be x to the 4th because I have 4 answers there. All right, so let's see. How do we come up with this polynomial? All right, well, we do x minus 1. Oops, that's not a 1. 1 minus the square root of 2. Okay, so we took this, put it there, times x minus, and it's always an x minus, and then we've got 1 plus the square root of 2, which is this, and then we've got x minus 1 plus 2i times x minus 1 minus 2i. All right, well, we end up doing the FOIL method. So we multiply these two together, and we get x squared minus 2x minus 1, because our radicals disappear. And then we multiply these two together, and we want to multiply those two together because they're imaginary numbers, or complex numbers. Ooh, that doesn't look too bad. I can multiply those together. So again, I multiply this times this, 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 and then this one, and then this one. And when I do that, I end up with like 9 numbers, but when I put common numbers together, like terms, I end up with this for my answer. Okay, so there is my equation, or my expression, with 4 as the leading exponent. That is the smallest number that I know each of these 4 go into. Could be a lot bigger than that. I mean, this could be 2x to the 4th minus 8x cubed plus 16x squared minus 16x minus 10. Okay, I just multiplied the whole thing by 2, and it gave me a bigger equation. Okay, so you can just, this is just one of many. Okay, well, this is the one we want. All right, that's it for 3.4a, and next video, 3.4b.